Hi, my name is Jenna.
And my name is Maddie.
And the title of our science project is Milk Mosaic.
For our science fair project, we are interested in studying chemistry, or more specifically, chemical bonds. Our experiment is to figure out how different fat components of milk affect the way color disperses when food dye is placed in the center of a pie tin full of milk and is touched by dish soap.
After some study, we chose to isolate the variables of the amount of milk that we use and the amount of food dye that we use in milk.
Our hypothesis is that if we use several types of milk when we test the food coloring to change the milk color, then different fat factors will affect the way the milk changes.
So through background research, we discovered that the reason the milk changes color is because the dish soap breaks the bond between proteins and fats in the milk. This allows the color to travel and twist throughout the milk.
In this experiment, we used materials such as pie tins, Q-tips, dish soap, food dye, and several different types of milk, including 1%, 2% fat-free and whole.
First, we poured half a cup of 1% milk into the first pie tin.
After the first step, we put in 4 drops of 4 different kinds of food coloring. This made it so that there were 16 drops total of food coloring per pie tin.
The next step of the experiment is to find a clean cotton swab and gently dip it into the dish soap. Next, you place a soapy end of the cotton swab into the middle of the milk, where the dye is. Experiment with placing the cotton in different places and even try twisting it in the mixture. You can see that we tried this out.
We tried this for the 3 other types of milk, which included 2% fat-free and whole.
When the milk and food dye come in contact with the dish soap, the fats and proteins that are held by the chemical bonds of the milk are weakened. The soap's polar or hydrophilic, which means water-loving end, dissolves in the water, and its hydrophobic, which means water-fearing end, attaches to a fat globule in the milk. This was stated by cspenglerscience.com.
The soap molecules move quickly to join up with the fat molecules, which causes the food dye's molecules to get bumped around. This is what causes the outburst of color in the milk. There was less fat in the 1% and fat-free milk, so the minerals were more balanced out, therefore causing less of a reaction.
We created our data table based off of the brightness of the colors that were showing in the different experiments. For the fat-free milk, the colors were dark and mixed together. The whole milk had bold colors like blues and purples. On the other hand, the 1% had colors lighter than the whole milk. The 2% milk had light, soft colors such as sky blue. We made our graph based off of the movement and speed of the changing in color. The fat-free and the whole milk traveled the fastest, while the 1% 2% moved at slower speeds. Our conclusion is,
we accept our hypothesis. This is because the 1% and 2% color change wasn't as dramatic as the fat-free and whole milk changes. This is similar to the real world because of the cause and effect relationships.